feel free to but we're going to go ahead and get started with the talk here. Okay, so welcome everyone for coming out. Hopefully this will be a nice, fun talk that'll also give you a little something to help you in your day-to-day work, some nice practical takeaways. So I'm Colin Jones, and this is my unpronounced Twitter handle here. And we're going to talk about JVM command line tooling. So a little bit about what to expect. We're going to be talking about command line tooling. I'm a big fan of the command line. I think it's fun. I think it's productive. It's fast. It's available on production hosts. The characteristics of the tools that I'm going to talk about today are not to say that other tools are bad and you shouldn't use the focus that we have today. We're going to be looking at some Linux commands, but mostly we're going to be focusing on cross-platform tools, and in particular, cross-platform tools for the JVM. So the JDK specifically, tools that ship with the Oracle, the hotspot, and the OpenJDK, not the IBM JDK. Some of these do ship with the IBM one, but I don't have a lot of experience with this, so I'm going to talk about some specific tools. Why don't you give me this other one? It's breaking up right now. See if this is any better. Okay, yeah, and even if you never touch the JVM day to day, I'd just like you to pretend that you do for the next hour, and hopefully you can take the lessons that you learn, and whatever your chosen programming language is, maybe some wiring issue or something like that. Okay, I'm just gonna. We're recording audio, is that right? Can I just ditch the mic or? No, I should keep using the mic. Okay. And more specifically than just JVM command line tools, we're going to be focusing on those command line tools that help you get to what's going on in your production system. So there's lots of great tools that don't meet all of these criteria. Those are great too. I love them. But we're going to be focusing on these. Structure of the talk is I'm going to share things that wrong with an app. These tools. In that, I found that learning and that will apply to you as well.
Test.
So the application generally works just great. In fact, we on the dev team are starting to feel a little smug, like this emoji here. We've got a minimum viable product. We've got some paying customers. Users are very excited about the time savings. Things that used to take them hours to set up in these various systems now take just minutes. Our feature delivery of the team has been consistent over the past several months. There are 0 known bugs in production. Tech debt is low. Test coverage is really high. The team is happy. Things are going well. Things are good. We have reason to be happy about this. Okay, so I'll give you just a quick glimpse into what the architecture looks like. You don't need to understand all the details here. We have some end users, both in a native mobile app, both Android and iOS, and some desktop browsers that hit a load balancer and go to a web and API application server. And that talks to Postgres, as does another JVM. And both of these application servers are JVM based. There's also one for periodic jobs that sort of pulls these various third-party services and a monitored email account dumps data into Postgres, and that's how they integrate. Right? So there's a few sort of interesting things about this architecture. I don't want you to dwell on it too much. Just pretend that this is fine. The code that we're going to talk about today is in this piece right here. So the reason I show you this is just to give you some context. This is what the project is that we're working on for the purposes of this talk. Okay, so the idea in terms of domain language is that there's an admin-facing web UI where the admins can sort of clean and improve this integrated data from all these sources, and then there's an API to present that cleaned up data to the end users. Okay, team's mostly happy. But I said mostly for a reason here, and that's that there's something spooky going on. I said that there's no known bugs. That's sort of a lie. There is a bug, but it's not really known. So maybe it's a known unknown or something like that. So I'm going to give you the information that we had at the time. Okay, we know that there is some bug. We don't know what it is, what's causing it, etc. We know that sometimes the server gets really slow. It might stop responding entirely, or it just might be like really, really slow, like it times out after 10 minutes. Unclear because the browser and the load balancer time out before we complete the requests. Okay, sometimes the team has to SSH in and actually manually restart the application server in order to get it started again. So that was sort of spooky before, and now I'm actually mad because I don't want to go and SSH into the production server to kick over a process and restart it. That's super annoying. We don't want manual processes like this in production. So apparently this happens, a couple times a week sometimes. Sometimes nothing bad happens for 3 to 4 weeks at a time. It seems sort of intermittent, unpredictable. We don't really know what's going on. When it does happen, when this issue arises, it's a huge emergency because the customers can't use the app at all. So this affects everybody. Like all the customers are just sort of in bad shape when this problem arises. Okay, so the good news is we've got alerts based on response time at the load balancer. So we get emails, like blasted with emails whenever this problem arises. We find out pretty quick when a customer runs into this. They don't have to actually email us or call us on the phone anymore. So we find out. Once we know, it takes like 5 minutes for us to SSH into the production host and kick over the process and restart it. But 5 minutes plus however long it took us to check our email, this is bad stuff, right? And so this is 5 minutes of downtime. Just could happen at any time. We don't know. We don't know when it's going to happen. So this is bad. The team hasn't yet been woken up in the middle of the night by the alerts. So maybe this is a coincidence. Maybe it's an important fact that we've collected here. Who knows? The good news is that the business has a fairly small, they're pretty new, so we got a fairly small number of customers they have to go and apologize to. The bad news is if there's a small number of customers, this is super confusing because we shouldn't be like suddenly super slow if there's hardly any traffic or hardly any customers, right? This is bad news. Okay, other details we know so far, the team has seen this problem a small number of times over a number of months. It seems to have gotten a little bit worse lately. Aside from this one issue, the team's mostly happy. Right? But this issue really causes some pain. This is an actual tweet from one of the developers on the project, name redacted. If this person knew about the tools and knew how to use these tools and had mastered them, the ones we're going to be talking today, they would have had a better time on this project. And I put this up here not to sort of point and judge and say, this person doesn't know how to use the JVM. I pointed out to show how demoralizing it is to have a production issue and to feel powerless to figure out what's wrong and to fix it. In the moving forward general sense. So it's really easy to assume, and I think all of us have done this, that the underlying technology is broken and not our use of it. Sometimes that's actually right. Sometimes the technology we're building on top of it, is broken fundamentally. It's not the case in JVM, I assert. But point being, let's not judge this person too harshly. They just sort of said on Twitter what goes on in most of our internal monologues. Okay, so let's take a step back from that. These are sort of the feelings that we're having as developers on the project. And let's review what we actually know so far. We know that occasionally, twice a week, once a month, the app becomes non-responsive. We know that it's not endpoint specific, it's not user specific. Everybody has this problem across the app. We know that the JVM itself doesn't go down because we have some upstart scripts that if the JVM actually crashed, they would have just been restarted automatically. And actually, that would have been great if it did go down. In this case, it's usually bad if the process crashes, but if it crashed, Upstart would have brought it back up, and everything would be fine. Because this is the last symptom here I want to cover, is that when you restart the JVM, everything's fine. Kill the process, auto restart it, everything's good for until 3 days or a month from now. Okay, so who thinks they know what the bug is already? And you can't raise your hand and answer if I've already talked about this with you. You actually already know if you've heard me talk about it. Any guesses? Garbage collection? Yeah, memory. What else could it be?
Load balancer?
Load balancer?
Yeah, stacking up using the load balancer.
Okay, so yeah, a bunch of networking connections, stacked up and yeah. Okay, so some queue somewhere filled up. What else could it be? Even assuming that you don't know, let's speculate and come up with some hypotheses. A deadline, great. What else could it be?
JVM program.
Or two? JVM's broken. Okay, yeah. JVM. Someone shipped me a bad JVM. Yeah.
Bad database query somewhere?
Bad database query, right? Yeah, you got some super slow database query. Sure. Some threading issue. So like maybe there's too many threads that are spun up and they're all context switching across each other and they're sort of fighting for CPU time. Or they're deadlines. Yeah.
Synchronous calls to downstream systems.
Synchronous calls to downstream systems, right? So yeah, maybe there's just too many calls that get made. You block on somebody downstream if they take too long. So it's similar to the bad database query issue. The more general case, not just the database, but any HTTP or TCP, whatever downstream system that blocks. Sure. Cool. So among these answers is the thing that actually happened. Okay. So I just want to encourage everybody it's great to speculate about what a problem could possibly be, but we really want some data to actually prove or disprove that speculation. If we have all these ideas, these 7 or 8 ideas that we just came up with, and then we allocated dev time to going and fixing all those issues or looking for them, we could spend weeks or months, who knows, like digging through potential issues and never come to the actual problem. So dev time is expensive. Fixing non-issues isn't actually going to help things. So we do have the right answer somewhere, but let's dig in and see what the data actually says, and actually find out what's going wrong for ourselves with these command line tools. Okay, so I'm going to figure out mirroring here. What's that? Great. Okay. So, I'm going to make a request here, just a baseline request. I think I've got the IP address in the window somewhere. Yeah. So I'm going to make a request to just the home page of this service. Okay, and we've got a bunch of stuff, but at the very bottom here you can see that it took 0.012 seconds total, so like 12 milliseconds. It's pretty fast. We make it a bunch of times, 15, 14, 12, 13, 11 milliseconds, yada, yada, yada. Pretty responsive site. And actually, I'm going to show you the home page of the site. Bear in mind, this is not a real site. This is a simulation. So what I'm going to show you is not the work of 8-Lice designers. Okay. It is responsive, though. So I just want to... I hope everybody appreciates how hard this is to do. And you can't use the blank tag in Chrome anymore. You have to use HTML5 CSS3 transitions or whatever. Okay, so before we do anything, let's just kind of get a baseline feel for these tools, because before we go into a production crisis mode, we want to know what the app actually looks like, how to use these tools, and what these tools are, so that when we're in crisis mode, we can actually just go ahead and apply our knowledge. Okay, so I'm going to go ahead and SSH into the host now. Okay, we're up. Okay, so first things first, let's sort of get a general sense for what the system's doing. And we use this tool called VMstat. This is not a Java-specific tool. This is a Linux thing. And it stands for virtual memory statistics, but it actually gives you a lot more information than that. You get information about what the CPUs are doing, user system, idle time, some other stuff. We're mostly idle on CPUs here. By the way, if you knew what all these abbreviations meant the first time you saw VMstat, that you're pretty amazing. So good news is though that all these tools I'm going to show you today have great documentation. So VMstat has some documentation here that gives you sort of a key. These had to be truncated to fit across many, many columns. So it makes sense that 2 characters is what you get. But yeah, you can take a look at the man page and see what the deal is. I wouldn't worry too much about all the specific things, but just know that VMstat will give you what the processors are doing system-wide, whether you're swapping to disk, how much memory is free, how many threads are waiting on processor time in the run queue, some other stuff like that. Right now, we're idle. This is VMstat. This is sort of a global system view of memory, CPU, and swapping, and some other stuff, I/O as well. Okay, so if we want to drill down a level lower than that and see which process is taking up resources, we can go to Top. Top is one of my favorite tools. I've used it for a long time. I just learned that you can do this cool highlighting thing that shows you which column you're sorting on. By default, it's like, what am I sorting on? I have no idea, so I just go all the way to the right and then go back over 2 columns. But anyway, Top also has a great man page. Super, super long. Still scrolling, still scrolling, still scrolling, still scrolling. You do lots of stuff. Okay, so the idea is that Top gives you a way to visualize what's taking up, say, the most memory or most CPU, which process is it. And in this case, Java's taking up more memory than anything else. Fine, 10% though. We saw plenty of headroom on our memory. And it also gives us sort of similar to VMstat some idea of what the system-wide CPUs are doing, what the load average is. That's a metric that involves the run queue size, how many threads are waiting on a processor or on processors. Okay, so Top gives us one step down, a little lower level. Is Java taking up a ton of CPUs? Java taking up a ton of memory? Okay, so that right there is where I would have stopped like 2 years ago. I would have said, okay, Java's taking up a lot of memory, Java's taking up a lot of CPU. Crap, JVM's broken. Or maybe not JVM's broken, but maybe just, I don't know what to do beyond that. So let's take a look at a really cool, at some really cool stuff. So we already saw the process ID of the Java process over here, 9611. We could also have gotten that via, PS, sort of a process list. And then, I'm always doing this PS pipe to grep Java. But the JVM actually ships with a tool called JPS that lets you do it a little more concisely and get the same information. So JPS, and then LVM are just some flags I've gotten used to using to give you a little bit more information about what flags were passed on the command line, etc. Okay, so that is the process ID, and for just about any use tools, you're going to need the process ID to interrogate the running Java process and see what's going on. So whether you use JPS or something like PSAX, whatever, but I like JPS just because it's concise, fewer keystrokes, it's convenient. Okay, now let's take a look at what all of the threads in this JVM are doing. So I'm going to use a tool called JStack. And then I'm going to type the output of JStack to a file, and those thread dumps are going to sort of give us a full picture of what every single thread, whenever I sampled in JVM, are doing, whatever one of those threads is doing. So we have one thread that's in runnable. It's called attach listener. This thread's called Grizzly Pool. This is doing some HTTP serving, I think. This one is waiting on the monitors. We've got a bunch of threads that are basically just sitting here waiting for web traffic to come in. Some ePoll stuff. And as you read thread dumps, you'll sort of get a better sense of what they do. One thing of note is that these thread dumps are not consistent. So you get a sample of each thread. It's not a sample, stop the world, where's everybody right now. It's sort of for each thread, where was that thread when I sampled it? Even though I called JStack one time, you're going to get the world stopped on that thread. at those moments. And I like to take 2 of them just because we are sampling and just because we get a specific stack trace at a point in time doesn't necessarily mean that that thing is always on CPU, that thing is always running. It might just be whenever we happen to sample. Okay, so yeah, thread dumps are great. They give you a great picture, especially for things like deadlocks. If we were to see that the state was locked, then that would be a really useful thing to have. Okay, so that's JStack. There's another tool called JCMD that is really interesting. Actually, before we go on to that, let me show you that, and I'll bump this font size up. These Java tools have man pages as well, manual pages. JStack, you can take a look at what all these threads are. You can make sure that you get your native C++ frames if you're using JNI or some native thing like that. Yeah, so it's got documentation right there on your Linux or whatever host you're deploying to. Okay, so JCMD. JCMD is another interesting one. JCMD's man page actually isn't that interesting. It shows you a few things, but basically JCMD allows you to connect to a running VM and sort of ask it questions depending on what's available in that JVM. It might have different commands, so in order to see what's available on this JVM, I type JCMD process ID here, help, and we'll review all these in a minute. But it shows me that all these things are things that I can ask that JVM. So I'm going to say JCMD, tell me what version of JDK or JVM am I running? I'm running Java 8. Oh, good. Like I wasn't actually accidentally running Java 7 or Java 5 or whatever. Cool. I can look at what the command line was that was used to start this thing. Get those details. Get the initial class path. You can look at things like the system properties of given JVM, and I can see what the boot class path is, what the file separator is, if that's correct, what my username of the JVM itself is, what the file encoding is, all kinds of stuff, any system properties. You can see there. You can also get statistics about garbage collection. You can get an entire heap dump. You can get a dump of the whole heap to be usually exported back to your machine and do analysis on there in some sort of GUI tool. This is a really nice one. Class histogram. GC.class. Okay, I'm going to type that last so we can see the top few offenders. We see that, up here at the top, of course, is a character array, is that what that is? Character array, byte array, Java class instances, some strings, hash map nodes, etc. Okay. There's a bunch of other stuff too. We're not going to go into detail on all these, but the idea is that you can get information about what's on the heap, how the heap looks, what classes are taking up the most room. The entire heap can get. You can actually run GC externally. That I haven't found that to be that useful for me personally. Maybe it's useful for others. The other interesting thing is flags. You can take a look at what the initial heap size was set to. Is this a reasonable heap size? Are these actually the things that I meant to be applied in my deployment process? Cool. And again, these things could change at any time, these options that are available. So it's a good idea to JCMD, pip here, and then help. And when I say they can change at any time, I mean with new releases of Java or new JVM versions. Okay, so JCMD is a really nice one. There's also, the last one I want to talk about is JStat. So JStat is a tool sort of like VMstat in that it gives you sort of a 1 second at a time or however many seconds you say, a running tally of what various statistics are over time. So you can see things like what the class loader is doing, what classes are being loaded, what's being compiled, what garbage collection looks like, etc. So I could say something like, if I want to know about the class loader, class 2611, I think. Right, I could see no classes, nothing's being compiled right now. If I give it some back request. Okay, so I'm not causing anything to be compiled. If I was, we'd see, oh, here we go. So this number changed. We loaded 2 classes between here and here. I went from 6231 to 6233. And there are lots of other things you can check out here too as well. Let's take a look at the garbage collection. So this is just essentially, give me a timestamp. I want to see garbage collection, summary, every 10 lines I want a header. Here's the PID, process ID, and I want to see it every second. So I can only see it every 5 seconds if I wanted to, not take up as much room or something like that. And again, these utilities have great documentation. So, I have no idea what these things mean unless I've, really familiar with Java garbage collection. But I can use this to find out. Just search for GC util on the main page, and we see that, okay, this is survivor space 1. These are the different parts of the heap. This meta space thing, I can go to Google and find out that it's about class and things like that. And the stuff at the end here is about when garbage collections happen and how long they take. Okay, so that's basically, those are all the tools we're going to look at. What I want to do now is show you what happens in crisis mode. In order to do that, I'm going to spin some load up against this server. And we're going to just go ahead and make requests to it as usual. So that, let's see, how long did that take? It seemed like a little longer than normal. Maybe not. So 76 milliseconds, just like 5 times as long as usual. Okay, but there's another 17 millisecond request. Make this smaller so those on that monitor can see as well. Yeah. Okay, so it's like over a second and a half sometimes. Okay, so something weird is definitely going on. Hide my secret load tester. Oh, that's a disaster. Don't want to see that. That's too annoying. Okay, 130 milliseconds. Over a second to respond. And if we leave this running, things are going to get worse and worse. I happen to know that. You can either take my word for it, or we can just sit here and wait until they start taking 60 seconds.
Wait.
No. We're going to go ahead and jump onto the host and see what's going on. Something funny is going on, even though we haven't completely crashed and burned yet. So let's go ahead and start going through our tools that we know about. What resources are being used on this running system? We have one thing in the run queue pretty much all the time, so somebody's always waiting for CPU. Memory looks like we've got plenty of memory comparable to what we had before. We're not really swapping. We did a little bit of I/O up here. We're definitely not swapping the disk at all. What else do we have here? We have the CPU time. 100% of our time is being spent in user land CPU. Okay, so we can sort of rule out kernel things like, is this making, spending a lot of time on network calls, whatever. But anyway, it's a CPU problem. We're CPU bound. CPU is spinning really hard. We went to top and investigated this. We would also see that CPU's pegged at 99%. Our load average is above 1. We have one processor. I just happen to know that from having set this VM up. I can see that there's one CPU core. Okay. Yeah. So we got plenty of memory left. There's many megabytes of memory left, and we're sort of pegged on CPU. And again, this is where I would have stopped 2 years ago. Okay, JVM's taking up a lot of CPU. Something's broken, right? So it's a CPU problem. I want you not necessarily to answer out loud, but think in your head, which of the symptoms that we described earlier would cause CPU to be pegged? Okay. And if you already know, that's great. If you don't, that's okay. So we're going to dig in further and see what the issues are. So we've got the same PID. Our process hasn't died. So I'm going to say jstack and dump into that file. Actually, I'm going to remove all the thread dumps I've written previously. Stack. Oh, sorry, this font isn't good enough. Here we go. It's probably better. Okay. So I'm going to take a thread dump. And when there's a lot of load on a server, JStack can be really, can take a while to execute. It's got to go through every running thread, wait for a safe point, make sure that it's actually safe to take a thread dump there, and then do it. And incidentally, I wouldn't recommend using JStack or heap dumps on production machines that are currently performing very well. If things are completely broken like they are now for me, go for it, right? You can't make it broken any worse. But go ahead and we'll circle back to that a little bit. But let's take a look at what the thread dumps look like currently. Okay, so now we have some threads actually doing some work. We've got a runnable thread that's doing some connection pooling stuff. Looks like it's using Hibernate. Okay, so Patrick's really happy about that. Okay, so here's some of our code. Party planning, API, V1 handlers, user search handler, complete. Okay, that's interesting. We have some of our code executing that's in search handler stuff. We've got some sort of recursive looking call here, longest common substring, search handler complete, some more Hibernate stuff. Okay, so this is sort of interesting. We have lots and lots of threads in Hibernate land, so that sort of suggests that maybe there's some sort of database thing, but it could still be lots of stuff. It could be too small of a connection pool. It could be the database is too slow. Could mean a lot of things still. But my point here is that the stack dumps, the stack traces, give you an idea of what's actually executing in the JVM, right? You don't have to worry about having a black box that says, okay, CPU is high. Okay, when we go through these, there's a ton of threads doing a ton of things. But all of them seem to have something to do with this, party planning API, user search handler complete. So that may be some interesting code once we've gotten the production issue fixed to investigate and see why so many threads right now are in that same place. And we'll just take a look at the second thread dump we took a few seconds later to see if things look pretty similar. And they do. Most of the same things are going on. Doesn't necessarily mean that those are the problem, but it's interesting that while the CPU is having issues, those things are all on CPU. Okay. So we already looked at all the JCMD stuff, although we didn't look at what things can change from JCMD one to the next. You're probably not going to have changes in system properties, hopefully. Command line stuff, that's not going to change. VM flags aren't going to change. Uptime will increase, we know that. Let's take a look at the class histogram. We could also take a heap dump here if you want. But let's see what's taking up the biggest percentage of the heap and whether we care about that. Actually, you know what? Before we do that, I'm going to bail on that. Let's even see if we care about the heap. So I'm going to go back to GC util jstat, this thing we did before, and see what garbage collection is doing. Okay, shrink it a little bit. Okay. So we can all see. Okay, so the heap, different portions of the heap. Eden space is pretty full. The old generation is pretty full. Ooh, the old generation space being full isn't good. Garbage collection times. Oh, we just had a 3-second GC pause right here between this line and the next one. Okay, I'm just going to kill this, the VM stat here, or the JStat here, and note that there was a full garbage collection here, a full garbage collection from here to here, and each time it's taking like 2 seconds, like 3 seconds, 3 more seconds. These are only 3 seconds apart, right? So if a full garbage collection takes 3 seconds, and it happens 3 seconds, 3 seconds, 3 seconds. Garbage collection is constantly running and trying to free up space, and it doesn't look like it's freeing anything up. Old generation is full now. Okay, so something's definitely going a little haywire with garbage collection, constantly GCing. So let's go back down to JCMD, and see what's actually taking up a bunch of heat. This sort of implicates garbage collection, which is interesting. We saw CPU as a symptom, right? We had plenty of headroom in terms of memory on the machine. CPU is the thing at a system level that looked broken. But we're spending all that CPU time garbage collecting, right? So it's actually, even though externally it looks like a CPU problem, internally to the JVM it's a memory problem. Okay, and if we look at these number of bytes, we see that it's a bunch of strings. And, usually you see strings accompanied by these character arrays. Also concurrent hash map nodes. Interesting, concurrent hash map, having something like that towards the top of the trace, or top of a heap dump, suggests that maybe we're leaking memory into that concurrent hash map and then never cleaning it up. Could be, we don't know. But that's sort of a question mark. And that's a piece of data to sort of write down. So at this point, I'm going to go ahead and kick the server over. Well, actually, you know what? I'm just going to kill every Java thing on the box. There was only one process that happened to know that before. Okay, so now we have a new process ID. Process is up and running again. And how are we doing? There we go. 8 millisecond latency, 13 millisecond latency. Okay, that's looking pretty happy. Okay, so now we're back to normal. And now we can go back and sort of review the data that we collected. Usually it's a good idea, like actually probably what I should have done here was take a heap dump just in case we needed to go back and interrogate that later. But I didn't save it to a file. But what we can do is we can look at these thread dumps. We can take the knowledge of we're looking for maybe a concurrent hash map. We can see if we can cross-reference these things back with the actual code itself. Which is a really good thing about these tools is you can actually relate them directly back to your code. So we're looking at user search handler complete. Things seem to be blocked in here somewhere. And actually, we had concurrent hash map as something that might be an issue. So let's just look through our code real quick for concurrent hash map, right? So we don't actually have to go through the whole process of debugging this. But we do see that there's a concurrent hash map here in our code. And actually, this was a place, this closest match finder was also a place that was in a bunch of the thread dumps as well. So that's sort of like a few symptoms maybe pointing to similar places. Maybe this is the issue. And it turns out it was, okay? So I'll skip right to the end here. This was the issue. We were trying to figure out what the closest match was between the search string and a list of the options that we get back. In order to do that, we computed the longest common substring. The algorithm we were using that we got from somewhere used a cache, used a little cache to make sure it could avoid doing work when it didn't have to. But this cache was used, we use a concurrent hash map instead of some weak hash map or some proper cache or anything. So the memory goes into the cache, and then GC can't ever clean it up. So that's just like memory that's just going. And as people put arbitrary text into the autocomplete box, our heap is filling up. So depending on what text people put in, if they're searching for the same thing, if they search for the same thing over and over, that's pretty much free, and that doesn't add any more memory. If they start searching for a lot of different things, or we suddenly get a bunch of new options in the database to match against, then we start having heap growth, and eventually we run out of room after 2 weeks or a month or whatever. Okay, so let's bail back out and review what we looked at. Cool. Okay, so what tools did we use to gather more information about this outage? VMstat we used to sort of get a picture of what was happening system-wide. We saw CPU, memory swapping, I/O. There's lots of other system-level tools that will let you get other pieces of information. I recommend Brendan Gregg's blog for pretty much everything. Top, we use Top to see sort of on a per process level who's eating CPU, who's eating memory. And then we got into some of the JVM's great tools. So JPS, just a typing affordance for me. What's the PID? JStack, this tool that samples the threads and tells us what they were doing. We don't get as much stuff as like a debugger would tell us. We don't get local symbols, local variables, stuff like that. But we get where the thread was executing at a given time, which is really useful. So JCMD just became available actually in Java 7. Before that, you had to use a bunch of different tools and stitch them together. You can use it to get a hold of system properties and flags. Before, in JVM 6, you could use JInfo for that. You can get class histograms and dumps like we saw. And for JVM 6, you could use JMap for that. But for me, I don't really use those tools anymore. That's why I didn't talk about it. The only reason you would use those, or I would use those, JInfo, that one you can actually change change flags in JVM. Some flags, specific ones. But I don't tend to use that a lot. It's something you can do that's good to know about though. So JStack, you can actually do the same thing with JStack, with JCMD that we did with JStack. You can like do JCMD PID and like something like thread.print or something like that. But JStack has not very much typing. And you can use your own shell wrapper to solve the less typing thing as well. But JCMD is a good tool to know about. Okay, JStat actually you can't. That's one of the few JVM tools you can't emulate with JCMD. That gives you the sort of second by second analysis of what's going on in garbage collection, class loading, compiling, etc. Okay, so we collected a bunch more data. We know that there's constant full GCs. We saw 4 to 5 second pauses every 4 to 5 seconds. We saw what's in the heap. We saw this concurrent hash map that was growing. So we could figure out, based on the contents of the heap, what's causing the GC pressure. And if it wasn't obvious from the heap dump that we got, we could have taken the heap dump and copied it down locally and done some visual analysis in the GUI. And from JStack, we knew what code was actually on CPU at the time. Okay, so of note is the fact that the autocomplete code was responsible for filling up the heap. Doesn't necessarily mean that that's going to be the thing on CPU at a given time. Right? It happens that my scripts, loaded up, basically just use the same endpoint to load up the heap. But it could be that whatever's responsible for loading up the heap, did so and then ran away, and then the code that you sample after the fact is still having issues, but it's not the thing that was responsible for filling up the heap. Does that make sense? So we had this unbounded, never expiring cache for actually what was at the time a pretty rarely used feature, which explains why it didn't happen all the time. And there was a memory leak. So high fives all around, we solved the problem. Great. Okay, so now all we have to do is fix the problem. We have a couple stopgap measures. We can just rate limit on the UI side. That's the easy thing to do. We can say, okay, only make one request every half second or something like that. That's a little slow. We can go ahead and ship that to prod as a stopgap though. Another stopgap, we can increase the heap size. That's a good idea. We have some headroom on the box. But that's actually just going to exacerbate it's just going to extend the issue. We're still going to have the same problem. It's just going to be 2 months down the road instead of just one. And it's actually going to make it a little harder to track down. Probably still a good idea because we have headroom on the machines. We could also do some sort of automatic monitoring and kill the process once the heap gets to a certain size. We could do that. It's less downtime if it's automatic, but it would still be a couple minutes of downtime in this case because we at the time only had one application server. Okay, so it's an improvement, but we didn't actually want to spend time there. We wanted to figure out what the root cause was and fix it. Okay, so idea number one, let's just eliminate the leak, right? Obvious first step. We've got a memory leak, let's get rid of it. So we want to use a real cache, use some soft references. Okay, so now the cache isn't unbounded, but actually when we tried this out, it wasn't totally locked up, but we still had multi-second response times, which was unacceptable for an autocompleter. And we went with these same tools and observed there's still too much GC pressure due to the cache. So question, which of the tools that we've talked about could we have used to find that out? To find out that there was still too much GC pressure due to the cache. Which tools? JStat, right? We use JStat to track the GC. Yep. And what would have told us that it was due to the cache? CPU. Okay, so CPU would tell us that the CPU was the constrained resource. JStat would tell us that there was GC going on. Where can we narrow it to a specific point of code and implicate that a specific class or a specific piece of code that would implicate, what's actually causing the memory to bloat?
JVM.
What's that?
The thread dumps with JVM.
Okay, so you can use you can get a thread dump with JStack to see where everything is in the code, and that'll tell you second by second what's executing on CPU. What would tell us what's in the heap? What objects are in the heap? JCMD. Yeah, JCMD also. Yeah. The class histogram would absolutely tell us that. Or the the actual heap dump, which we didn't actually look at because it's a binary dump and it's not too interesting to look at. Yeah, absolutely. Right. And by the way, JCMD is almost always the right answer for these because it can do a lot of things that are different. Yeah, absolutely. Okay, so this wasn't good. Tip number 2, what if we don't use any cache at all? Okay, so now we don't have a cache, but the algorithm sort of depended for performance on having a cache. And so the whole reason to introduce a cache to begin with is to improve performance. So presumably, if we remove that cache, performance is worse. And in fact, it was. The request took way too long. It filled up the request processing thread pool, leaving no other threads to service the traffic that was incoming. So this was another one of the theories that we had earlier, was that some queue fills up somewhere. We don't have any more threads to service it. What tools could we have used to find that out? To find out that the autocomplete requests were taking too long.
Curl.
What's that?
Curl.
Curl? Oh, okay, sure. Sure, yeah, absolutely. You could just become an end user yourself and not actually introspect on the JVM. Yeah.
JCMB.
But say that again?
JCMB. You said that.
JCMD? Yeah. Yep, JCMD, right? It's always the right answer. Correct? Yeah. So one option would be to use JCMD or JStack to get a thread dump and just take thread dumps over time to see that these things are always on CPU. This thing's always running. It's just taking a really long time to run. We can look at the garbage collection summaries via JStat to see that it's not garbage collection that's taking up a lot of time. There's no full garbage collections going on, but we're still slow, right? So what else could it be? CPU, some sort of CPU thing, and the information about what's running is in the sectors. Okay, so this was definitely no good. Okay, now we come to my favorite idea. This one absolutely worked in staging. Turned out it was a no-go from a business perspective. The client says this is actually core to our business, is being able to save people's time. That's our whole point, our whole reason for being, saving people's time. If we don't have autocomplete, that's going to be a huge pain. People are going to have to type it all out. Okay, but business does say we can, if we need to, keep the site healthy, we can turn it off for a couple days, as long as we know we've got a full solution coming, in a couple days or something like that. So temporarily maybe okay, but not obviously the full solution. Okay, so we know what we want to do. We've got an autocompleter. We want to do autocompletion. So the thing to do is have an actual search engine, right? We'd love to just take our query results, sort them by closest match, exactly as some sort of full text search engine would do. We don't need to do this, in a custom way in our code. This should be something that's built into our whether it's Elasticsearch or Lucene or Sphinx or some built-in Postgres thing or something like that. To use that for our relevance ranking and not try and do that in memory in the JVM. So, a sort of specialized custom solution. Not custom, specialized solution to integrate. So we looked up at a few possible solutions. We ended up going with Postgres full text search. We were already using Postgres, and meant just keeping that one piece of infrastructure in place and not adding a new piece that we had to learn to operate and everything. So that made the most sense at the time to get it fixed out quickly. And it worked pretty well. There was some indexing and query syntax to learn, but after a few days, the leak was gone. The thing was fast, and it was in production, and it worked. So we feel pretty good. Unfortunately, we didn't get the happy, after picture, the I love the JVM tweet from that particular developer from before. Maybe that ship had sailed. But I think it's important to remember that production incidents like this are going to happen from time to time, right? It might not look as awful as this sort of unbounded cache. This person doesn't know how to use Java. They wrote this memory leak where there's a concurrent hash map being used as a cache and never cleared. But it might be something like unbounded queues. That's an easy one to run into, or some sort of unbounded thread pools, or unbounded waiting for an external resource. And I think it's important to know how you're going to respond before you have an incident in production, so that you can focus in the moment on collecting the data that you need to go and do the fix later, to figure out what's actually going wrong. So there are a few takeaways I had, and a few things I learned from this process that I'd like to share. One is that something being slow could mean a ton of different things. It could mean your first reaction may be like mine. Oh, it's probably the database, or you get too much JavaScript stuff going on, it's definitely that. And to devote a few weeks of dev time to fixing that thing. But it might not find the issue, right? How likely are we to just, by guesswork, find that one section of code that is actually causing the problem? We might already know, right? There's definitely those times where we already know what the problem is, and we guess right. But there's lots of possibilities. We've enumerated like 8 of them before. Even something as specific as high CPU doesn't necessarily mean what you think it does. When you've got garbage collection in the mix, high CPU could be a memory problem, right? So the resource that's constrained might not be the one that some of your tools tell you is. So it's good to know, to collect more data and find out more details to figure out where the issue lies. So I think particularly when you're in crisis mode, it's extremely important to be focused but not rushed. So if the bug's a new one, of course, just go ahead and roll back immediately. If you just deployed, performance tanks, everything's toast, go ahead and roll back, that makes sense. But at least you should probably figure out the basic things. Take a couple thread dumps, check system level stuff, figure out what resources being constrained. If you know these tools really well, it can just take 5 minutes to check all this stuff and at least get a high level picture of what is being constrained, what's going wrong. And after those 5 minutes, yeah, definitely roll back. Or maybe you can do it quicker than 5 minutes, or maybe you have automated tools to collect that data for you. But checking those things, then rolling back, it totally makes sense. Cool. Garbage collection logging, I think, is another really important thing. When you've got a tool like the JVM, you can just set a flag to throw garbage collection logs on the file system so that you don't even have to run JSTAT. You can just look at the logs. They're always there for you. And then that saves you the time of having to go back and check what garbage collection was doing when you're in a crisis. You can just look at the logs. So collect as much information as you can about the logs when they occur. So I think it's important to remember that my immediate thought, or it was important for me to remember, my immediate thought at seeing that there was a memory leak was, okay, yeah, we fix that, just make it a real cache, ship it to production, let's go. But that wouldn't have worked. We would have said, hey, client, Mr. and Mrs. Business Person, everything's fixed. I just shipped. There's no more memory leak in production. But it still would have had the exact same symptoms, right? That would have been super painful to have to go back to the client again and say, okay, sorry, we got this issue again. Everything's broken for 5 minutes for all your users. Right. So I think it's important to be able to reproduce a bug first before you try and apply the fix that you know is the right one. We could reproduce it in staging, so that's really happy. That gives us a higher level of confidence that once that problem is gone in our reproduced environment, that it's actually going to be gone when we go to production. So I can't overstate how important it was for us to be able to reproduce problems outside of actual production, or at least in an environment that's not mission critical. Maybe that is production for you, and you can just have some small amount of traffic going to this one spot that you change out. So it's not always feasible, but I think we should push to make it feasible to be able to reproduce everything just like it is in production. Otherwise, how do we know that the fix is actually going to help? Okay, so we've already alluded a little bit to this, but I just want to give a shout out. There's a ton of other good tools out there besides these sort of JVM built-in command line ones. There's heap analysis tools. I'm not going to name specific names, so I don't really have a favorite, but you really need some sort of visual tool to track down things like class loader leaks that are such a pain to dig into. And really, like anytime you need to do any sort of analysis in memory, you're going to need some sort of visual tool, or there are query engines and stuff that allow you to make queries that are sort of SQL-like across a heap and see what objects are taking up the most room and what sort of relationships exist. But for me, I find that I really need a visual tool for those sorts of things, and that's not something I can do on the command line with any ability at all. Profiling is great as well. I know JVM is the one that's bundled with the JDK, and it works pretty great. The newer one, Java Mission Control and Flight Recorder, is really cool. It's like way better than JVM. If you're on the JVM and haven't seen Mission Control yet, you should check it out. It's really, really neat. And YourKit, I know some of my colleagues use that, and it's supposed to be pretty good too. But profiling, of course, basically lets you attach a GUI to a running JVM and see in a more visual way what's going on. You can look across all your threads. So, when we looked at the stack dumps earlier, there was a sort of wall attached. You see the whole stack at once. Profiler might allow you to see all the stacks at one screen at once, moving over time, and seeing what's locked at a given point and what's running. way easier to see deadlocks with Profiler than it is with JStack. And of course, like ideally, we have sort of persistent, pervasive monitoring and learning. We can see some dashboard somewhere what's happening at runtime using like Coda Hale's metrics library or something like that, where you can get insight into as many problems as possible without having to resort to like SSHing on the machine and checking things out. So seeing graphs and metrics over time in particular is really useful to get a sense for what trends are. Right? Are we always spiking at 9:30 a.m. Or is this just like something really bad going on today? And finally, the last category of stuff is dynamic tracing, which I've gotten really into and written a couple of blogs about recently. Really exciting stuff. Again, check out Brendan Gregg's blog. He's from Netflix for basically anything performance related. He's a really great author. It's really exciting stuff, and there are even some tools that let you sort of couple dynamic tracing with some other technology that he's written, and I recommend definitely that you check those out once you got a handle on basic tooling. Okay, so just in wrapping up, places to learn more about this kind of stuff. I'd recommend these books very highly. They're definitely not the only books about these topics, but they're all really good ones. Definitely recommend them. So Released by Michael Nygaard, Java Performance, Definitive Guide by Scott Oakes, and System Performance by Brendan Gregg. Definitely recommend all those. And of course, remember that you've got all these bits of documentation also right in your terminal. You can, command pages and these various JCD help command issues are super useful. Of course, we all sometimes have to Google for stuff and look up documentation. It's really great when it's right there in your terminal. So yeah, use your powers wisely, and thank you for your time. So I'll post a link to the slides on the meetup group later today. I'm happy to stick around afterwards and answer any questions or discuss any of these kinds of issues that people want to talk about afterwards. And if you're watching on the internet, feel free to ping me on Twitter or elsewhere. Thank you.